Number 10. The elements iodine and tellurium have similar average atomic masses. A sample that was believed to be a mixture of iodine and tellurium was run through a mass spectrometer, resulting in the data above. All the following statements are true, so they're all true. Which of the following would be the best basis for concluding that sample was pure tellurium? So notice this graph that it shows is only something about the mass number. It doesn't tell you anything else, right? It tells you nothing about polarity or polarizability or the charges or whatsoever. So take a look at the answer choices. First of all, look at A. Tellurium forms ions with -2 charge, where iodine forms with -1 charge. Once again, that's wrong. The graph only solely tells you anything and everything about the mass and mass only. It doesn't tell you anything else. So that's why anything that is irrelevant should be eliminated. B. Tellurium is more abundant than iodine in the universe. Well, I don't know if that's true, but even if it were to be true, what does that have anything to do with the idea of, this graph right here mainly being pure tellurium? This really doesn't say anything about it. So I'll just put a question mark right there. C. Iodine consists of only one naturally occurring isotope with 74 neutrons, where tellurium has more than one isotope. That could potentially explain why. What the hell is an isotope once again? Well, isotope is something that is mainly the same atom. So like, if we talk about carbon, there's carbon 12 and carbon 13 and carbon 14. They're all carbons. They're all carbons, but they just have different atomic masses and therefore different number of neutrons. Because how do we get atomic mass? It's just basically the protons and neutrons added together, right? So isotopes are basically same element that have different amount of masses and therefore different number of neutrons. So maybe the whole idea of tellurium having all these different isotopes, maybe that's what creates all these different bars indicating they're all of all these different masses, versus iodine only has one naturally occurring isotope. So if that were to be true, well, then we should be looking at only one very high peak if this were to be an iodine graph, right? So this could potentially be true. I'll keep that. And in this sense, this makes a lot more sense than what choice B has to say. I will now get rid of it. Choice D. Iodine has a higher first ionization energy than tellurium does. Now, that talks about ionization energy. What is ionization energy? Well, that's the amount of energy that is required for you to remove an electron. So first ionization energy to remove that first electron, which once again has nothing to do with this mass number table or the graph that we have in the question. So that's why it's completely irrelevant. It's not going to explain anything. You get rid of D, and that's why answer should be choice C.